If you go on our website, you will probably see this phrase labeled a lot: the Cell Inc., the BioConvergence company. And so that's a new phrase. And so what does that mean? And I think that'll be the first thing we cover in the agenda. After that, I'll talk about the 4 ways of actually interpreting Cell Inc. Before we can move into some Q&A. And so, bioconvergence is really motivated by this idea of the need for tissue repair. Human health might be the most existential problem that we face, right? And so at the same time, these large problems also create wonderful opportunities to make progress. However, we're not going to make progress on these opportunities if we're not moving forward in an efficient manner. And currently, there's a lot of inefficiencies in processes, such as the long process it takes for a drug to go from research to approval, which can take 10 years on average and result in $2 billion of wasted revenue loss cost. And so we believe that this paradigm shift towards bioconvergence can actually be useful on the way to addressing these goals of tissue repair. And so what bioconvergence is really motivated by a historical context, this historical sort of trend where as the technology is allowed to develop, it will inevitably attack or intersect these existential goals, such as human. We've seen this in the field, like, for example, of computing, the rise of that in the 1950s to what it is today with personalized computing, how these massive improvements in computing power have intersected with biological fields, DNA, structural bio, the study of how molecules are assembled and interact. And in doing so, created the birth of brand new fields. Fields like multiply parallel computing and high-powered systems to make sense of the genomic DNA we get, or protein, the ability to model these things, model these molecules, and then also create them. That is a pivotal area of therapies today. These are fields that didn't exist 10 years ago, 20 years ago, that have only come about through the combinations of technologies that were initially separate but intersected along the way. And so by that vein, the technology that my company specializes in, 3D bioprinting, as I'll demonstrate, is really born out of an intersection between this fields of biomaterials and industrial additive manufacturing, all towards this goal of advanced tissue repair. And so, it's the story that I've come up here is the 4 ways of interpreting Cell Inc. And it's heavily based on my personal experience as a graduate student who specialized in this technology of 3D bioprinting. So when I was about a 3rd-year graduate student, I first became aware of this company, Cell Inc. And at first, I thought it was interpreted cell link, like a links of a chain. And to me, that made sense instantly. Because, as I said, working in this field of tissue engineering, the way that we grow cells is predominantly done in what's known as a 2D fashion. So in this manner, you've probably seen this before. The cells are plated at the bottom of a petri dish, and then there's like a media overlaid them. If you toured W Firm Anthony Atala's lab, you've definitely seen this. And so the problem with this, though, is that in our body, the cells are not organized in 2D layers, right? And we can look at some of the things that are lacking in this format. For example, cell signaling. The cell isn't able to communicate really to other cell types or more cells of the same type. It's an unnatural environment. This liquidy environment doesn't replicate the type of solid tissue structure that our body inhabits. Altogether, this is a non-native biology. And so to me, there was a lot of rooms of improvement. That's kind of why I went into grad school to study this topic. And the field of choice that I chose, tissue engineering, was essentially based around this idea that if we're able to construct more realistic models of cells, really by extending them into 3-dimensional, to go from cellular model into tissue model, we can start to replicate much more of the environment. We can start to input much more information to the cell. We can give it mechanical information. We can start to integrate multiple cell types, as you see here, to adopt some sort of cell signaling. altogether creating a more physiological system. And more physiological systems are, they advance our way to advanced tissue repair. They can be used for drug screening and drug efficacy, so to reduce some of those costs. So there's immediate and long-term advantages of adopting this 3D cell culture approach. So it made sense to me. Of course, it's a company that's going to be started around this realm. And I determined it was actually Cell Inc. So just the 2 L's there. And while think surprise, but to me, again, it made perfect sense, but only because I was in this niche study of 3D bioprinting. So 3D, of people who are unaware, is essentially the same as 3D printing. So you can take where you take a computational model, as you see here, you can go from a computational model into a printed structure. We'll see one of our bioprinters printing the butterfly structure out of just a very base hydrogel material. But you can imagine, when you're trying to build tissue structures, that material could actually contain cells. It could contain stem cells. You could print different organ structures. And you can start to compare in different cell types, as I did with the blue and the black here, to really try to replicate the composition and hierarchy that tissue. And so when you look at, this has been shown in the literature that the list of bioprinted tissues it virtually covers every human organ there is. And, it all started with, Anthony Atala at W Firm presenting the kidney on the stage of the TED Talk. I don't know if it's that far. It's really funny because his gloves are actually way too small. But that's the photo that becomes associated with bioprinting. So I chose my butterfly here. You can definitely find a bioprinted analog of any tissue you were interested in. And so what Cell Inc. was really meant is that it was focusing in the bio inks. If we use bio printers, they need to have ink, right? And so it's about the same price as normal ink cartridges, surprisingly, maybe not surprisingly. So Cell Inc. originally started as a bio ink company with the first universal standardizable bioink alginate in 2016, and since then, after they later became a bioprinting company, and I think that's part of the projections that the entire bioprinting market, because the bioprinting is really a workflow, is expected to grow up to around $4.5 billion by 2028. So we feel pretty good about where we're positioned. I just want to give you guys some actual examples of how bioprinting is being used in research, and so maybe some of you are familiar already. So but this will be good for those who are not. This is a work from one of our partners out at Rensselaer Polytechnic Institute. And so here they used one of our systems to create a multi-layered skin model. So here you can see the 2 different colors, the purple and the red. These are different bio inks. And so you can see what they did was they constructed 10 layers or so of the skin model using the purple ink, and then they overlaid the 2 layers of the red ink, which contained a completely different cell type meant to mimic the different layered structure that skin actually has. And so you can see that layering of the structure here in these confocal Z stacks with the green and the red overlaid. And I thought what was really interesting is that when you do these histological, is what it's known as, is chemical staining of the skin, of natural human skin up here, and you compare it to the bioprinted skin, you can see how closely the 2 actually resembled. In fact, the bioprinted skin even seems more ordered or more structured, but you can see it still maintains the positive expression of these really key marker proteins. Another example that I presented particularly of the interest at the Life Science Northwest conference is idea of immunoncology. So using the body's own immune cells to treat its own cancer. And so one of the ways that we're working with pharma companies to this end is by leveraging the natural abilities that 3D printing provides. So essentially, the fact that these are machines so you can run them all day, all night, and generate a lot of number of samples. So this is a function that we have on one of our machines known as a droplet printing, which is really useful in generating a high throughput, small scale samples of these spheroids you can see here. So again, it's a 3-dimensional cellular structure instead of a 2-dimensional monolayer of cells. So there's a lot of benefits to that. And so what they did was, not only is this mimicking what a solid tumor might actually be like in your body, there's some differences in the cellular composition. But what the researchers in our department did was that they had these spheroids dispersed throughout these little red circles you can see here. So you can imagine these are the spheroids, and they incubated around them the T cells that were programmed to attack and kill the tumor cells. And so what you would expect is, if you increase the concentration of the number of T cells, you would start to see more killing of the tumor, right? This is just a workhorse assay that any immuno-oncology company needs to do to prove that their therapy is working. And so we demonstrated that with this high throughput bioprinted tissue model, you indeed can get this assay to work. As we see here, as we increase the number of the T cells in the media, the fluorescence, which is a marker of a number of live cells in here, starts to go down. Right, and so you can see it here. This is a cell that doesn't have any of the killer. This is a spheroid that doesn't have any of the T cells around it, and you can see it's much brighter than this spheroid, which has undergone a lot of cell death. Great. And then finally, as a company, we rely on our customer success for our own business, and so I just wanted to highlight one of the companies that, in particular, we partner with, Roanoke out of Kansas, which is a two-person company, but they've done very amazing things for being two people. They have this they're using our technology for this really fascinating application of creating tissue blocks. So again, instead of doing the cell culturing on the bottom of a flat dish, actually making like Lego pieces out of tissue. Seeding is the word, stem cells all around it. And so what you can do, there's a lot of benefits to that. Not only is it a better structure, but you can also increase the density of the number of cells that you get. And so they find a 30 times stem cell yield in this method compared to conventional 2D culture. So they recently received a COVID remediation grant and underwent a positive, I think, $5.4 million in Series A funding. Yep. And so we're really happy for them. So yeah, I think that brings to the other way of interpreting Cell Inc. is that as our business has grown, we've also moved from just being a bioprinting company to being a lab automation company. So, I can speak from my experience as a graduate student. There's a lot in the lab that can be automated. There's people spend 2-3 hours a day essentially doing the same repeatable process. And so for the amount of training that these people, postdocs, graduate students, have to go under, it's really a waste of their time and of their potential. So, if as a company we can start to automate some of those tasks to let those students focus more on the idea end, we view that as a win-win operation. And so in that line, we've gone to live cell imaging, bioreactors, really anything that can be automated in the lab. And if one of the examples of this is the BioMDX, which is we have coming out this summer, completely automated, fully scalable, so many material extruders. It's really this thing can replace the work of 3 graduate students. 27 microplate slides. So that's one of the products that I'm really excited about and coming in this summer. And yeah, so this is the end. I just want to shout out my company and all of our partners. As I said, I did connect with Todd through LinkedIn. I am a sales executive. So with that, you could probably figure out what the fourth interpretation of Cell Inc. is. But really, we love our partnerships, and we're always going to do the customer right at the end of the day. That's what they say. I haven't seen that refuted yet. So that's all I have for you guys. Thank you so much again for the opportunity to present and informative presentation. Having trouble finding the
Hey, Todd and Daniel, thank you so much.
Here we go. Yeah. And I'll be happy to take any questions.
Yeah, that's great. Hey, Daniel, can I just say that I took advantage and didn't tell you up front, but I had recorded it. Is that okay with you?
Absolutely.
Okay,
no
great.
Problem.
Because, I'm a former sales guy myself, and there's not a better position in the world when you have a new technology or a new device or a new therapy and this was very exciting. So I do want to open it up to our team if anybody wants to ask you questions. There was one or two in the chat.
Bladders, that's right. I apologize for that. Yes, thank you for that correction, Patricia.
I think Kathy Bakit asked, she may have dropped off, but I think she asked if you're in trials or if any of your therapies are in trials.
They're approaching that status. So the ones that are so bladders are the are the ones that first made clinical trials, you know, and the other ones that we're starting to see come around are skin and cornea. Largely because those are kind of the, you know, the low-hanging fruit, simpler biological structures. But hopefully down the road, you know, the visceral organs like heart and kidney and liver would be in, you know, I would project 5 to 10 years, starting to make their way into clinical trials.
All right, there. That sounds better, doesn't it? How many cells have you put together in a you know? You were showing some examples with 2 cell types, but like 3, 4, 5.
Yeah, that's a great question. So I think the most I've seen is 6 cell types. But yeah, certainly you could go up to double digits.
Now we're getting this ready.
How do you have a question?
No, I think that's really cool, some of the stuff that you're doing. It definitely goes along with what they're doing at WFirm, because they are doing some really interesting stuff and trying to get that several layers of the organs and everything worked out, because that's one of the biggest issues that they're having. They had to figure out the scaffolding to start with, and then they had to move on to the rest of it.
Jennifer, you're still with us, and you're a health IT person. You must have a question that's lingering in your mind.
Actually, that was pretty deep science for me, so I think I'm good for now.
Very good.
I was curious about the Kansas team. So that was a 2-person company, probably a few more people now. But they basically made a product using your technology.
You're on mute, Daniel.
You're asking about Roanoke?
Yeah.
Yeah, it's they're in over, I think, 18 countries now, 5 continents. It's amazing what they've been able to do. So they have 6 of our Luminex bioprinters, and they have a very hardworking technician who is able to crank out a lot of these tissue constructs. But they are scaling up in both. They just got a new lab space, and I think I've hired a few people as well.
Okay.
So Daniel,
I was having some.
Go ahead.
Sorry, I was having some mic troubles during Patricia's question, but yeah, I just wanted to follow up with her. I see, Patricia, do you have some experience on the research end, or what is with the regenerative medicine community, or do you work with them?
No, it's one of the most interesting places that we ever go, and whenever I just think about leaving teaching, that's where I always think about getting a job.
That's awesome. Yeah. It seems like you really have a good knowledge and passion for it.
Yeah, and Daniel, we had another grant which both actually Todd and Patty were a part of, where we would actually go around North Carolina in a van, if you can imagine. It was a 15-passenger van, and we would visit sites, and we would actually have people go into the organization, do a tour, and in many cases they did some hands-on stuff. So, it was a really great program. It lasted 6 years. We had 60 people go through. But I have a question. I have a question for you, which is a little bit more pertaining to the workforce, and that is, I noticed that you have a PhD, but you did mention, and I'm assuming your PhD is in biology or some related science. But my question is not really that. It's more, you mentioned that this is growing, beautiful market growth, $4.5 billion by the year 2028. you know, what kind of programs do you guys have for like a work study or an internship? And do you look to entry-level technician opportunities for people?
Absolutely, yeah. It's we are a very strongly growing company. I've only been with us for about 3 months, but already I've seen about 30 or so hires in that 3-month span, and so yeah, we've been able to maintain growth through COVID, which I thought was really impressive. And so yeah, we're actively hiring on all areas, from business to engineering side. So we do have some summer interns. I know it's a thing. I haven't really investigated around it yet, because I think it's more on the engineering side than the department that I work in. But I would be happy, if you have if you want to publicize any kind of program, I'd be happy to have a flyer for our internship. And so yeah, in terms of engineering, we have a manufacturing plant in Salem, Virginia, which does all of our printer manufacture. And so I would know they would definitely be interested in entry-level research technicians as well.
That's great. Anybody else got any questions? Deb, you're...
Yeah, I do. You mentioned engineering, Daniel. I was thinking about material scientists. Are there, how does a traditional material scientist, fit into what you're doing, or what's the correlation between the biological level understanding and material science?
That's a great question. I think material scientists are the most powerful bioprinters there are, because really the tissue engineering is a subset of biomaterials, which is a subset of material science. So, the material scientists heavily overlap with the 3D bioprinting community, because, when you're a material scientist and you're trying to apply for grants, it often helps to have a medical application in focus. So we have a lot of crossover with material scientists, and they do some of our most fabulous work, because really what the process is in the materials end, making it more both printable so that it can hold its structure, or that essentially that it can replicate the natural tissue structure, right? And so that requires actually heavy collaboration from the material scientists with the biologists. And so those are the labs that we really want to get our technology in the hands of, because you no longer need to be a mechanical engineer to do this type of work. It just requires a very fundamental level of instrumentation knowledge, which most of these researchers have. So absolutely, material scientists and biologists, I think, are the main benefiting audience from this technology.
Thank you. I was hoping that was the answer I was going to get.
Yeah, absolutely. I love material scientists. Yeah.
Well, I'm pushing to encourage material science professors to encourage biological information in some of their content. So thank you.
Daniel, I have a question for you. So if some of your clients are going through clinical trials, so what kind of regulatory compliance issues your company is facing right now? Do you have any interaction with the FDA requirements, anything like that?
Yeah, that's a good question. Yeah, we're actively working with the FDA to make to push our products through those regulatory protocols. So all of our machines right now are currently R&D focused. So they're not CMGP compliant, but the BioMDX, which is scheduled to come out summer 2021, is under development to be CGMP compliant. So that's why I'm really excited about that machine, because it's going to open up a lot in terms of actually getting having these technologies as a part of clinical product production.
Okay.
Yep. Thank you for that question.
Any other questions? I have a question for Jennifer. Okay, so it's not like Jennifer's question, but it's what I think that Jennifer might want to ask. But she said her plate is full of science today. So Daniel, how many of these processes are going to be computerized and run by, let's say, artificial intelligence, that kind of thing? That's where I'm going with this.
Yeah, I mean, I don't have a good number for you. It could, I think it depends on the time scale that you're looking at, right? By 5 years, maybe 30-40%. By 50 years, probably everything will be automated at that stage. So I mean, it just goes to show that, I guess, that a lot of these, unless it's really intelligent, creative work, working in the lab, can be fully automated, and that's what essentially the field is trying to do with this technology, with miniaturization of the lab, which you see like on lab on chip solutions too. So all of these different fronts kind of working to the same goal of making space more efficient and effective and automated.
Yeah, with the W firm people here were just awarded by the community. You may have seen this in the news, but they were awarded an award for their lab on a chip.
Oh yeah. That's amazing. Yeah. Do you know the name of that award? Actually, I haven't seen.
I think it's called the Winston-Salem Community Award. I can send you a link on it.
Oh, okay. I feel like I have heard that.
Yeah,
that would be great. Yeah, I'd appreciate that.
But it was essentially Dr. Atala's team, and it was
right.
a community workforce or a community event with the what we used to call the chamber, which is called Greater Winston-Salem Inc. And their team was recognized by the community for this achievement, which I thought was pretty cool. Yeah,
that is pretty cool. Yeah. Please do send me the link.
Yeah, I will.
Right.
Sen Young, anybody else got any others? How about from our grant people? Amy's always got a great question.
No, it was fascinating to listen to it. Anytime you all start talking about some of this, I just remember back, when I was an undergrad and we were just getting into genetic replication and stuff like that in the early 90s, and just to see how far things have come I'm not that old, in my lifetime, is pretty amazing.
Yeah.
And what I showed you is just the tip of the iceberg. Actually, we invite me back and I'll show you the real cutting edge stuff as well.
Yeah, I'm kind of interested in the you had in the middle slide a bioreactor.
Yeah.
Yeah, and because kind of these small scale bioreactors, and getting to so like, are you growing CHO cells in them? Are you what's tell me about that?
Yeah, I mean, so the newest one is actually growing organoids in them.
Okay.
So no longer being restricted to a single cell type, and CHO cell not being restricted to the easy to work with cells, if you will. CHO cells are very hardy, right? But actually growing very sensitive, delicate cells like stem cells in large scale bioreactors, and growing them in 3D structures. So as spheroids, as organoids, which we know, the tissue engineering research has shown really beneficial for maintaining their phenotype.
Yeah, and so if you do that in a bioreactor, I mean, what kind of scales can you do? I mean, or are these going to be like hormone level compounds where you just a little bit goes a long way? What's kind of practical? Do you have a sense?
I mean, I think one of the beta islet cells would be one of the first bar.
Wow.
That he froze.
There, implantable pancreas to help treat diabetic patients. Hello?
Yeah.
Yeah, or boy, just being able to grow a pancreas, so people with pancreatic cancer, you could take it out and then put in a new one.
Yeah. Hey, Brian, do you have any observations?
Yeah, I think that it's great. That's fascinating work. I think one thing that I don't know if you all have done it yet, but one of the critical things, especially about organs and a lot of tissue, is that they have blood flowing through them. And so I think that's something else that you're going to need to evaluate, like with stuff like skin and things like that, dermal tissue, et cetera. That's a little easier to get at, but when you have vasculature feeds that need to go to a lot of these to make sure that the material lives, and then can then sort of self regenerate, a self repair. That's the other piece to get at. So I think as you look at the evolution of your platform, one is that you have the cells and the tissue, and then the next stage is, can that tissue repair itself, similar to the human body? That's another step. So I think that's something else that you'd want to get as you evolve the platform.
Yeah, absolutely. I think you hit the nail on the head there, that the tissue vasculature is one of the major obstacles to the translation of this therapy. It's a great point.
Yeah, so Daniel, just to give you a heads up, Bryant is a seasoned executive, having been in the biomedical device industry at the high C level, and is now Director of Strategic Partnerships at University of North Carolina at Chapel Hill. So we're just delighted to have him on board. He's been our chair of our advisory now for several years. You know, he's also, he did his PhD at Chapel Hill, so he's kind of a Tar Heel kind of guy. You know, we're okay.
Oh,
with that.
wow.
Yeah.
Very, very cool. Yeah, it's a pleasure to meet. Did you get, are you a biologist by training?
No, my PhD is in biochemistry.
Biochemistry. Very awesome. Very cool. Yeah.
Yeah.
PK curves. Yeah.
And was that a big C little b or a big B little c?
What was it? I didn't get that. What?
Oh, biochemistry. I often refer to it as the big B little c or little b big C.
Yeah. I guess big. I saw the mixture. My undergraduate degree is in chemistry.
Okay.
Graduated from the biochemistry department, but it was more biophysics. My advisor was a PhD physical chemist.
Nice.
So we had to take. I start shuddering when I think about all the other stuff that we had to take in physics and quantum mechanics and all that. So anyway, but in there.
Well, are there any other questions for Daniel? I'm not hearing any. Daniel, I want to thank you for joining us today and taking this time out of your day. Are you up in Boston right now, or where are you? You're kind of.
I'm in Seattle, actually.
Seattle.
You can see.
Pretty cool.
Yep.
Okay, excellent. Yeah. Great. I love the way you're kind of hanging out. You might be outdoors. Are you outdoors?
I am. I'm at a Starbucks right now. I'm getting my second vaccine dose later this afternoon, so I had to drive a little bit to a location.
Okay, great. Which one are you getting?
The Moderna one. Yeah.
Good. I can attest. It's a good one.
Yeah. Russ was in the trial.
Yeah.
Oh, really?
I'm wondering when I'm going to get my booster, because it's like 9 months ago that I had my last shot. So, yeah.
I got my second Moderna shot last Friday, but it was tough. Saturday I couldn't do anything. Yeah.
Yeah. Right. Yeah. Thank you so much for the opportunity.
Thank you, Daniel.
Yeah.
Thank you.
It's a pleasure. And thank you for letting us record it as well. I really appreciate it.
Thank you.
Thank you.
We'll be
absolutely. Please feel free to share it liberally.
Yeah, thank you. Yeah. Anything else for the greater good for the team? Jennifer, any questions from you? CyberBio is coming along really well. Patty, you want to give a 2-second update of where we are, sort of thing?
We've kind of got the whole schedule worked out. I'm getting ready to set up, or actually I was going to talk to James about setting up a Canvas page or something where everyone could access the information. I've got Todd's slides to start building the glossary off of, and I was starting to work on the glossary for the bio terms, because I think that's where there's probably going to be the most need, is the bio terms, instead of maybe so much of the cyber terms.
Yeah, the Tracy Cresswell lecture went really well. She, most of us who have done that tour of WFIRM or have been associated with WFIRM have seen her present before, but I think she's really honed it in. So as soon as she gives permission, I'll send the link to the whole group. But she really did a beautiful job. So we're looking forward. So we have a couple of more of those to record, but then we're off to the races. So I just encourage anybody who your classes or whatever, anybody that you're interacting with that sort of qualifies, they're either a teacher or an instructor or a professor, if they want to take the program, we've got the space. So they should definitely sign up. It's 6 hours total, 3 days of 2 hours each. So, yeah.
Hey, so speaking of CyberBio,
it's like a long lunch.
It might be a total of 10 hours with
And if
the
you
other
and if you
lectures
and if
thrown
you
in.
went and think about it, if you went to lunch, wouldn't you want to talk cyber bio?
Well, yeah. So speaking of computers and things, I'm always sending Patty random things as I come across. But there's a podcast that Sandy and I just listened to. Luke Timmerman, he's a biotech reporter here in town. He's got his own gig now with the Timmerman Report, and he's been doing these podcasts. And so he talked to Amy Duras, and I'm not remembering the name of her company right now, but they built an informatics platform for doing T cells and all the CAR T, and because the whole provenance and knowing that Russ, if I take your cells and I engineer them and I put them back in you, what we really want to know is they're your cells.
Whoa.
And and that's a big deal. And one of the things they did is they got into the FDA. The FDA says, look, you don't necessarily have to use their technology platform, but how do you manage this? You have to have a data management plan and a provenance plan. And so the whole point of that is these systems are critical to the production of certain classes of therapeutics going forward. I mean, you just can't do personalized medicine without dealing with the fact that each unit, each small unit, each person is a batch. So that was a really good podcast. I was going to reach out to her because I thought she'd be good, a great one to try and get on one of our calls.
Yeah. Well,
Yeah.
Todd, you bring her in if you can. And that's great. And absolutely. Yeah. No question about it. I mean, that's goes for anybody else too, that if they think they've got something that's very targeted and they would like to have them come to the program, please do. Yeah. It's great.
Yeah.
It's what we're trying to do.